video. And today, what we're going to be doing is going over the definition and the lesson of derivatives. So, let's get started. And first question what we have to ask is, what is a derivative? Okay, so a derivative is defined as basically it's the rate of change of a function. Now, what does that mean? So, let's say we have the function y f of x equals x squared. Okay, this is a pretty common function in the math world. You see it a lot in algebra, algebra 2, maybe math analysis. And let's graph this function real quick. So let's just do a little sketch. Alright. Sorry, pardon my terrible drawing abilities, but okay, let's say this is the graph of x squared, y equals x squared, which is the function, okay? With respect to x, or d of dx. Basically, this is the rate of change, also known as the slope of the function. So, whenever we want to find the derivative at x equals any value, you just need to find the slope of the function at that specific value. So, let's say we want to find the derivative of the function at x equals 1. So, this is how you write that. F prime just means the derivative. And so at f equals f prime of 1, at x equals 1, this is what the function should look like. Sort of like this. And say x equals 1 right about here. That looks about right. So, sorry, I don't know if you guys can see this or not, but if we want to find the slope at x equals 1, you have to draw the tangent line. Or, this is basically drawing a line that kind of shows the slope of the line at which x equals 1. So let's say we want to find the derivative at x equals 1 here. Right here is this is the point. Well, the slope of that would just be equal to the slope of the tangent line, or this line which kind of hits the curve at one specific point. So if you want to find the derivative at x equals 0, the tangent line would intersect with this at one point and it would just be straight. And you can do this for many different points. For example, if you want to find like the derivative at x equals 1/2, you can just draw the slope of this. Say this is x equals 1/2. Just draw the line that's tangent at x equals 1/2 with the point at x equals 1/2 on the curve. These are some pretty terrible drawings, but I hope you get the gist. So if you want to find the slope of f prime of 1, that's just the slope of the tangent line, which is basically the line that intersects with the curve at exactly one point, the point at which x equals 1 on the curve. And how do we actually find this value? So let me just draw this again. Say x equals 1 right about here. Okay, so how do we find this tangent line, this line, and how do we find the slope of that line? Well, there's something called a limit, and limits are basically if you set the limit of a variable to something, it's telling the variable to approach a certain number. It's approaching a certain number, but it's not actually getting to that number. So let's say the limit of x approaches 0. That's how you write that. That's the notation. This is saying evaluate this function. Let's say there's a function here. Saying evaluate that function as if f approaches 0, but it doesn't actually reach 0. So it's as close as can be to x being equal to 0, but it doesn't actually reach 0. Let's demonstrate this with the function, let's draw a random function, and we'll see what this looks like. What happened, I had a little bit of technical difficulties, but let's draw the function for the limit of x approaching 0. So let's say the function is something like this. So y equals 0 for all x for which x is not equal to 0. And then let's say at x equals 0, y equals 3. Now, if you want to find the derivative, so this will show you what the limit is. So let's say we want to find the limit of x approaches 0, which is stated right here. You might think, oh, if x goes infinitely close to 0, wouldn't it just be the value at x equals 0? However, this is not the case. So the value of x, the limit of f of x as h approaches 0 for this graph is not y equals 3. Instead, it would be because x approaches 0 and does not get infinite and gets infinitely close but does not reach 0 yet, it has to be this value right here. And this is a hole in the graph, so this is y equals 0, which is the correct value. Why is this? Well, when x approaches 0, it gets infinitely close, so it follows this line and this line. So it approaches 0. The standard x arrow value just means it approaches from both sides. So it goes from the negative and the positive side. There are kind of signs where you can do x approaches 0 from the positive side, which means it goes from the right to the left and then approaches a certain value. But all of this is that as x approaches a certain value, it doesn't reach that value. It gets infinitely close, but it does not reach that value. So instead of the limit of f of x as x approaches 0 just being f of 0, which is this value up here, it would be this value right here because it approaches but does not reach that value. And so how does this relate to derivatives, and why bother doing the limit of something? Well, for starters, the derivative can also be defined through limits. So the limit definition of a derivative is just f prime of x equals f of x plus c minus f of x divided by c, or the change of x. And this is all the while the limit of x c approaches 0. So this can be for any value of x in the function. Excuse me, let me just make this a little bit clearer. So let's think back to the definition of the derivative, or basically the slope of the function at a certain point. Let's say we want to find the slope of this value. So y equals x squared x equals 1. We want to find the derivative at x equals 1. What we would do is find the limit. Well, first of all, we can't ideally find the limit, the slope of this line from just one point. We need more information. So, what a strategy that mathematicians use is they use 2 points. Let me just change the color real quick. So, instead of just using 1 point and getting an exact value, we can use 2 points to approximate this value and thus find the line that goes through these 2 points. Now, it's very easy to find the slope of a line from the 2 points that you know. So this would just be, you can use the point slope form, or you can use the slope intercept form, right? So let's say the coordinates of this were x1, y1, and this was x2, y2. The slope of this would just be y2 minus y1 divided by x2 minus x1, right? Simply just the change in height over the change in y over the change of x. Now, how can we use this to find the slope of the tangent line hitting this singular point? Strategy that mathematicians use is we say that there are 2 points that are very, very close to each other, that are just outside this point right here. So let's say on this line, this is the point, and then let me just make this clearer. So let's say this is the point on the line, and then we want to find 2 points that are very, very close, but not like approximately the same point, but are just a little bit away. And then we can use the thing we did up here to find the slope of the tangent line. And the way you can write this out is through limits. So we can say that the distance between these 2 points, let's say this point is x, y. This point will just be, or y is also equal to f of x, right? This point is x plus c. Let's say c is just a random number. That's the increase in horizontal distance from the first point. And then let's say the y equals f of x plus c. Well, if we set c to the smallest possible value, which we want to do, we want to estimate that these 2 points are exactly the same place, basically close to each other. They're just squeezing infinitely close to each other. Let's say limit of fc approaches 0. So basically, the distance between these 2 points approaches 0. It gets so close to 0, but it just doesn't reach 0. So it's a little bit above 0, which is what we want. And it's what's going to happen. And this kind of approximates for just the slope of the tangent line, as these 2 points are like right outside the line. And it's a rough estimate, but because we're approximating c to approach 0, it's such a small value that it comes to 0. It basically is the same thing. So let's say the limit of c approaches 0, and then we can use the same thing, right? So f of x plus c, which is the second point, it's y, as you can see in this equation. And then f of x, which is the first point, y, divided by the change in the distance of y. So this is just x plus c minus x, x2 minus x1. So this is just c. Now we have our classic definition of the derivative. For the last part, I'm going to teach you how to find the derivative of a function easily. and it's going to be a lot easier than the limit way. It's going to be a lot simpler, and you're going to understand once I show it to you. So, one sec. Let me just clear everything. Brush. I think it might be just easier if I fill everything white. So. Yeah, it should be good. Okay. So now we're going to learn about the power rule. Now, okay. Let's say you have the same function y equals, or f of x, doesn't really matter, equals x squared. Instead of finding the limit of this, instead of finding the limit of c approaches 0 and doing all of that for a certain value, what you can do is use the power rule. So what the power rule states is that if you have something, an x variable, uh, or the variable that you're taking the derivative of raised to a coefficient, you can multiply by the coefficient and then subtract 1 from the coefficient before. So let's say x squared, the coefficient is 2. So you times the thing, you multiply by 2, and then you multiply by the variable to the coefficient minus 1. I mean, to the power minus 1. And so this is just 2x. And you can see if it's x cubed, you can see that the exponent is 3. So 3 times x to the 3 minus 1, which is just 3x squared. And you can do this for anything. Now, this is only for if you have the variable you're trying to take the derivative of. So let's say you have 4x cubed. There already is a coefficient on there, so if we take the power rule, excuse me, you can use the power rule, multiply this by 3, and then take the coefficient minus the exponent minus 1, and you will get 12x squared. And for all constants multiplied in the equation, you just keep them there. You only take when you're doing the power rule, you only take the exponent and multiply it, and then take the variable to the exponent minus 1, raised to the exponent minus 1 power. So now we know the power rule, and we can also do for other scenarios, we can use the constant rule as well. So let's say you have y equals x squared plus 7. Well, as we can see, there's no value of x. What does this mean? Well, there actually is a value of x. It's just x to the 0, and that's why it's not showing up. Because anything raised to the 0 equals 1. So x to the 0 equals 1. So we can rewrite all constants as the constant c times x to the 0. What does this say in the power rule? Well, if we have something to the power of 0, and we multiply by 0, which is what the power rule states to do, we just get 0. So we can ignore all constants. Additionally, there's something called the sum and difference rule. So basically what this says is if you have something you want to take the derivative of, and you can take the derivative of one thing, added, and you can take the derivative of another thing, but they're added together. You can just individually take the derivative of each and add them up, and you get the same result. So let's say you want to take the derivative of this. Y prime is just, what's the derivative of x squared? Using the power rule, it's 2 times x to the 2 minus 1, which is just 1, plus x, which is to the power of 1. Using this rule, the power rule, we get 1 times x to the 1 minus 0, which is just 1. I mean, x to the 1 minus 1, which is 0. And then 2 times x to the 0. Well, what is this? This is just 0 times. We don't even need to calculate the rest because 0 times 0 is just 0. 0 times anything is just 0. So when you're adding this, you can negate it. And so we get y prime of this equals 2x plus 1. And these are the basic rules you need to know for right now. In the future, there will be different rules, such as there's a rule for multiplication as well as division. But we'll cover that in later videos, and you don't need to know that right now. So let's recap some key points of today's lesson. You can take the derivative of a function, and the derivative is defined as the rate of change of a function at a given, the rate of change of a function. If we want to find the derivative of a function, we can use the limit definition as well as the power rule. Now, it's important to have an understanding of how to do both, and the power rule is also linked to the constant rule and the sum and difference rules. And the power rule states that if you want to take the derivative of a function based on a value, a variable x, you can simply take if there is a quantity which is x raised to some power, you can simply take the exponent, bring it down as a constant, multiply it, and then multiply it also by x to the raised to the x raised to the power minus 1. The constant rule states that you can ignore all constants being added or subtracted simply because they are multiples of x to the 0, and this cancels out to 0. And the sum and difference rules state that the derivative of the different quantities being added together is just the sum of or difference of the quantities derivatives themselves. And let's quickly revisit the limit definition as well. So limits are defined as when you assign a variable to approach a certain value. It can be anything. And this is where the variable gets infinitely close to this value but does not exactly reach that value. So it's basically at that value, but it's off by a tiny bit. So this is useful for when you have functions with holes or perhaps breakages, or perhaps like jumps, and you can set the limit of the function at a certain value to find what it approaches at that value. So This is also useful for calculating the derivative of a function. And thank you guys for listening. I hope you guys learned a lot, and I hope you guys understand now how to perform the basic uh, forms of a derivative and how to do the derivative using the limit rule, the power rule, and hopefully there's going to be more to come. So stay tuned for another episode on another video on how you guys do multiplication or division derivatives. And yeah, thank you guys for listening, and see you guys later.